Hello, everyone. It's nice to be here, especially as it's the first talk in this Mobile Warsaw season. My name is Michał. I work on Apple platforms at Stoic, and today we'll be exploring the on-device LLMs with this new foundation models framework. So over the past 2 years, the large language models, LLMs, have shifted from novelty to everyday. They have transformed how we write, code, and search and do many different tasks. I think we can say with great certainty that we are experiencing a great revolution, and there are a couple of factors that explain this moment. So first of all, the models are getting much better. When we started integrating the LLMs in our app, it was like 2 years ago. We were using GPT 3.5 Turbo and then GPT-4. So they were good, but not as good as today. The requests took even 20 or more seconds for larger input. And over these 2 years, we got more models to choose from other providers like OpenAI or Anthropic. They are getting better, they support reasoning, and they are just easier to use because, for example, you've got an option to generate the structured output, and you don't have to care about how it looks because it will be delivered in a JSON. Also, there are just more tools to choose from, and yeah, we can experience the LLMs in different forms, in different applications on everyday use. So apart from having these massive models, on the server side, the on-device AI is emerging as a complement to the cloud counterpart. It allows us to run simpler tasks locally, while offering the lower latency and stronger privacy. In this session, we'll talk about the newest framework from Apple called Foundation Models Framework, which was introduced at WWDC in June. It allows developers to take advantage of the on-device model that also powers the Apple Intelligence, while keeping everything more secure and fast. We'll go through the basics, capabilities of the framework with some examples, and in the end, I will show you the use cases that we have implemented in our app that supports this new framework, and yeah, we made it available with the iOS 26 release, which was yesterday. So when it comes to using the LLMs from the mobile app, the most common approach would be to call the third-party providers in some way. So the most common way is to use some kind of backend for it or call it directly, but we'll focus on the server first. Actually, I wanted to ask how many of you have added some kind of integration to how many of you have added the LLM integration into your mobile app in the past? Okay, I can see a couple of hands. Nice. Yeah, so you probably went with this solution, but I might be wrong. The most common way is to just have a server that maybe acts as a proxy for making the request to some third-party providers like OpenAI or Anthropic. You can also host your own model on the server if you want to have some special use cases for it. It's also a little bit more private approach since the data is not shared with the third-party provider, but it also comes with a greater cost and more maintainability. On the other hand, you could embed the model on the device, but there are also some drawbacks to it, especially prior to Foundation Models Framework. And yeah, prior to the Foundation Models Framework, if you'd like to embed the model into your app or make it available to be downloaded, you could just take a model, export it with for example, PyTorch, and then convert it to CoreML so that it's compatible with iOS. Then you would establish a baseline and make some benchmarks to see how it performs without any optimizations. And then you could go and do a couple of more steps. And now, yeah, finally, you can use your model in your app. The main problem here is that the model is still huge. After optimization, it can take like 4 gigabytes in size. So even if it's downloaded after the app is installed, because you probably don't want to embed it in the binary. Imagine if you got like 10 different apps and each one of them uses some kind of model. Yeah, you end up with a lot of space being taken by these various models. And that's when the foundation models framework is like a good news for us, because it provides the access to the on-device LLM. Basically, it's used for generating the text based on the prompts. Also supports the guided generation, which is something is what Apple calls the structured output. And since it's the offline model and it doesn't have like a world knowledge, you can expand it by calling the tools. So about the model details, these are the details for the current release of iOS. It of course may change with the next update. The model is 3 billion parameters. The context window is 4096, and it's a multi-language model as it supports 16 languages, but unfortunately no Polish. When you start working with the framework, the object that you will spend like the most time with is the language model session. It's just an object that represents a session that interacts with the language model. By default, it uses the default system language model, which under the hood uses one of two use cases, the general one. So it's a generic model that is useful for variety of application, but it is not specialized in any particular use case. It can be used for just general purpose text generation tasks. So the second use case is content tagging, and it's supposed to be used for extracting the tags from the text that you provide. I will mention it a little bit later in the talk, because we tried it and we didn't get a results that we wanted with it. Going back to the model session, that's how you define the instruction, which is like the system prompt. Instructions define the model's intended behavior. And Apple trains the model so that it obeys the instructions over any prompts. So yeah, the instruction has a higher priority than what is later provided in the prompt. When you want to make a basic request, that's how you do it. You've got various variants of this respond function. But yeah, you can just pass a string to it. You can also provide some options, which are defined by the generation options model. There are a couple of parameters. The first one is sampling, which is the type that defines how values are sampled from the probability distribution. In this case, we're using greedy, which will always choose the most likely token. But there are also some other options where you can specify the probability threshold and seed and other stuff. The second parameter is a temperature. It's a numerical value from 0 to 1. It affects the response in a way where the lower value will produce more predictable output, while the higher value, with the higher value, the model can be more creative. So as I've mentioned, it's between 0 and 1. it used to be between 0 and 2, like 2 months ago. They changed it for some reason. I think in GPT it's also from 0 to 2. And you can pass nil. And if you pass nil, the model will just decide what temperature to choose. The last parameter, pretty self-explanatory, maximum response tokens is just the maximum number of tokens that the model is allowed to produce in its response. So with this like super simple and probably not very real world scenario example, I just wanted to make a point that the session is stateful. So once you have an instance of the session and you make another request, it will be part of one session. So if we ask this question, the model, since it doesn't know about it, it will say something like you can see on the screen, that it doesn't know how to provide the information. But if we prompt it with this information and then ask about it again, the model will be be able to provide this information. The point that I'm making here about the stateful session is also quite important, because when you've got the context window, everything that you put here and you get from it will count towards the context window. When working with the session, we will probably encounter some errors, which are of the type of generation error. I have listed a couple of examples, the most popular examples. The first one is assets unavailable, and the second exceeded context window size and guardrail violation. The first one might indicate that the assets required for the session are unavailable for some reason. And if you want to know this reason, you can check the availability. So here in this switch case, you can see and check the reason. So for example, if the device is not eligible, it says it means that device doesn't support foundation models, because they are not available on the older devices. For the second one, Apple Intelligence not enabled. So for example, in this case, you might want to show some kind of message to the user and tell them that they should go to the settings and enable the Apple Intelligence. Also, the model might not be ready, because it might be still downloading. It's not on the device when you install the update. Yeah, but you may also get a unknown reason, and actually, I'm not sure how you should handle it. If you don't care about the detailed reason about the unavailability, you can also just check the is available flag, and it will return true or false. And if it's true, you can proceed with the request. The second error that I would like to talk about is exceeded context window size. So it will signal that the session reached its context window, which is 4096. The token count includes instruction, prompts, outputs, and in general any text that you provide to the model. A single token corresponds to 3 to 4 characters in languages like English or German, and 1 character in languages like Japanese and, for example, Chinese. When you get this error, you can recover from it, because once you've got this session where you have exceeded the context window, you can, for example, summarize the whole response and feed it into the new instance of the session. So yeah, that's one way of recovering from it. The last error that I'd like to mention is guardrail violation. So Apple implemented some safety features in order to prevent generating unsafe or harmful content. It might appear like couple of times when you are working with the model, and it's probably normal, but if you keep requesting for the same prompt and receiving this error, there is something wrong either with your instruction or a prompt, so you have to just adjust it. There is also you can also like suppress these guardrails by passing the permissive content transformations. It's supposed to be used for the text summarization, which may include some potentially unsafe content. When it comes to the structured output, Apple provides these two macros that you can assign and annotate your model and properties. It's a generable and guide. By default, the types that support generating content is bool, int, double, array, decimal, and float, apart, of course, from the string, which is like the most basic type. So let's say we want to generate a list of irrational numbers. By default, if we use the default respond function, we will get a text, something like you can see on the screen. But since we want to get like numerical values, we can change it and pass the generating param and define the output as array of doubles, and then it will look something like this. But let's go even further and use custom type. So, for example, here we've got the irrational number, which looks something like this. By default, it will just throw an error because it's not suitable for use with the Apple Foundation framework, but we can easily fix it by providing the generable annotation. As you can see here, we also use the description, which will inform the model and give it more context about what this model is about. We can also annotate the properties, like here with the guide. And apart from the description, we can also set some constraints, like you can see with the value property. So here we're defining it to be between 0 and 20. And actually, it's super useful thing because you don't have to define these kinds of constraints in your, for example, in your instruction or in prompt, but it's being done on the model level. Yeah, it's just much better and easier to use. So with this kind of custom struct, the output might look something like this. So we've got name and a value, and in the future it can be easily expanded. We can easily add another properties to it. So yeah, I think it's a way to go in most cases when it comes to generating objects. Another thing that Apple provides is called tool calling. So it allows so since the model is on device and it doesn't have any additional knowledge, it cannot call the internet on its own and download some more information, but we can expand it and provide this kind of information with the tools, because the model can now call any code in our code base. And it's the model's responsibility to call the tool if it thinks it makes sense based on the prompt. So to define the tool, you should conform to the tool protocol and provide a name and a description. So in this case, we will be creating a tool that basically returns size for the file that we provide. As the input, we can also provide the arguments struct with one parameter, which will be file name, and then the call. In this example, it's a struct, but tools can also be stateful. You can change it to class. You can maybe cache some data between the calls that you want. So it's up to you. When it comes to the session, that's how you define the tool. You can pass the array of tools, so there can be more than one. And let's get back to the call function. So for this prompt, where we ask what is the file size of the presentation.key, the function will take the argument, and this arguments.file name is equivalent to presentation.key. So the model knows that it should call the tool, and it will extract the important input that it wants. Then we can take it. For example, call our service. It's an async function, so it will be non-blocking. Then we can do some formatting with it, and in the end, we can provide a return value as a string, as just a natural language text, which will say presentation.key is 1.9 megabytes. I think a little bit more convenient way of working with this call function is to replace the string with the generated content object. I think it gives us a little bit more flexible. It gives us more flexibility because we can just define the key value pairs of the object that we want to return. And now, when we make this request and ask the question again, the model will come up with its own output based on the tool that we have integrated. It will say something like the file size is 1.9 megabytes. But I think it really shines, especially because it might call the tool multiple times. So in this example, we are asking which file is bigger, photo or video. And in this case, it will detect that we've got like two input parameters, the photo and video. The tool will be called twice with each parameter, and the response might look something like this. It will compare the files and provide us with the information that we wanted. Without the tool, it would probably hallucinate or wouldn't provide any information at all. But yeah, here we've got like a simple working system where you can prompt it. A little bit more advanced technique is something called adapters. So they adapt the LLM with new skills or domains. They are more advanced because you have to train the adapter on your own. You use Python and PyTorch for that. And one important thing here to notice is that when you train the adapter, it's trained on the model that is used by the OS. So for example, when new OS comes out and it contains a new model, the adapter that you have trained before won't work. So you will have to retrain it again. The adapter files are quite big because they are more than 150 megabytes. So you won't probably include them in the app, but download them later. Actually, I didn't try it yet, but wanted to mention it because I think it wasn't mentioned during any WWDC session. It was buried somewhere deep in the documentation. So it's just so you know that something like this also exists. When it comes to the UI and making a request again, we've got a couple of more options. So with the previous examples, we were using the respond function, where it would just return a value at once. But we've got this function called stream response that returns a stream that is basically a wrapper for the async sequence, and then you can use the for loop to populate the property that you want. Also, when you are using the generable, like in this case we are doing with the pizza names, you can use something called partially generated, and it's used for representing of partially generated content. So you define it as optional, and now automatically all the properties of it are optional. And it's very useful when you're working with UI. For example, in SwiftUI, you can define it as a state, add like one line of code to provide the animation, and the output will just start appearing on the screen, just like that. So it's quite useful if you don't want to wait for the whole response to end, but to stream the content as it's being generated. When you will be working on the prompts, you will probably spend most of the time changing the instruction, because it's like the main thing that is in this framework. There is a very useful playground that you can now embed in Xcode. It's a little bit like a SwiftUI preview for the code. So that's how it looks in Xcode. You can inside the playground you can define a session and then make responses. And on the right, you will have all the information that you need. So your session instance, the input, the output, how much time it took to generate each prompt. You can also file a feedback. It was quite useful when working with beta software, because if you saw something weird, you could send a feedback to Apple. And I tried working with it. It worked a couple of times, but actually most of the times it would crash my Xcode or even my Mac. So yeah, maybe it will get better, but we even tried opening the code that handles the foundation frameworks, because it's in a separate package, in separate Xcode window, and yeah, it would also fail most of the time. But yeah, it's useful while it works. So to summarize the framework, there are some key points that yeah, I think are quite important to remember. So first is that the session is stateful. So when you make next request, it will contain the context from the previous ones, and all the text input and output that you get counts toward the context window. You can check the availability before making the request, which might be useful to prevent having some errors. Then you can use generable and guide annotation for input and output. And in order to expand the model's knowledge, you can use tools. When it comes to the UI, stream response together with the partially generated that you get when you define the model as a generable can be useful for your UI. So for the second part of the presentation, I wanted to show you some examples that we have implemented during the summer, and we shipped it in our app called Stoic. So one of the use cases, the first one that I wanted to mention, here we've got a screen where user selects a mood in their daily check-in flow. And based on the flow, we wanted to show a short gratification to the user. These mood levels are defined as a numerical values from 0 to 4. And at first, when we fed the mood as a double to the model and wanted to map it to some kind of the response, it wouldn't work very well. So yeah, it's probably quite important to map some kind of numerical value to the model representation. That's also true for dealing with data, for example, from health kit, like heart rate readouts. The model is just not too advanced to be able to make any sense out of it. So yeah, in this case, you can just create an enum and map these values. And it's quite important to give examples. So like in this case, we've got these instructions, which relies on the instructions builder, where you can mix parts of the text and also put your output. This gratification model is actually the output of the host response. But when you're dealing with the examples, make sure to indicate that the example should not be taken one to one. It should be probably rephrased because most of the time, especially with the lower temperatures, we would get almost like the same output as was defined in the example. So there is some things to consider. Another use case are the prompts that are displayed for the quotes that you can browse in the app. So as you can see in the top, we've got this view where user can tap and open the journaling. And as you scroll through the list of quotes, sometimes you will see that it appears. In some other cases, it won't be shown. So we wanted to make sure that the generated content actually makes sense. We wanted to just generate something and show it to the user. So at first we created like a bigger task with a bigger instruction where we first wanted to generate the content and then in some way rate it to be sure that it makes sense. But in the end, we ended up with like a simple pipeline where we are using two instructions. The first one is responsible for generating a prompt for the quote, and then we take the output from it, feed it into another session where it's responsible for grading the output, and yeah, I think the results are much better. Another example are the starting prompts to help user with their journaling. So here we've got the guided journal flow, and above the keyboard you can see these little pills that you can click on, and yeah, they basically are supposed to help users start writing, because the start is like some of the times the hardest part here. And since our app might use different language than what is defined in the system, so for example, in the system you can use English, and in your app it can be Spanish, the model has to know about the locale that you are using. By default, since you define your instructions and prompts in English, it will respond in English. There is no way to like pass a parameter that will indicate what language should the output be. So we've created just a simple extension which inserts this instruction that you can see on the screen before any content of the instruction, and it works pretty good. But of course, it won't work like 100% of the time. The last use case that I wanted to show is tagging the user's input. So by the way, the Apple Foundation framework works not only on iOS, it also works on macOS and Vision. So the user can type something, and then under the hood, after they finish writing, we are doing some categorization. So as I've mentioned before, we use okay, yeah. Maybe the video, and so yeah, here you can see the categories. Before I mentioned that there is a special use case for content tagging. We started with it since yeah, that's what it's supposed to be used for generating tags based on the content. And it worked pretty well, but the main issue here was that it didn't provide exactly the information that we wanted. For example, when you mention some name or some place in the input, with the content tagging use case, we wouldn't have these names included in the output. We would just get some more general info. So we switched back to the general use case. We have made some changes to the instruction, and as the output, it looks something like this. So we've got just some properties with the arrays of strings, which are these tags that we want to generate, and yeah, it actually helped us with generating what we wanted. So when it comes to the use case summary, I think the main takeaway from it is to keep the prompts and instruction short. Also map any numerical values to the enum or other type of your liking, but yeah, the numerical values won't work particularly good. Also provide examples, but not too many, and state that the model shouldn't exactly copy these examples that you provide. If you have some more advanced use cases, you can split them into smaller ones. Of course, it will take a little bit more time because you are making 2 requests, but it actually might work much better. And if you support other languages, add this information to the beginning of the prompt. So as we wrap up, it's clear that the on-device LLMs are quite exciting step forward. Of course, they are not quite ready to replace the cloud solutions. If you asked me how would I rate the quality of the generated content, I would say it's like not great, not terrible. It's decent, especially if we think that it runs on our mobile devices. I think this hybrid approach, where you've got some simpler tasks running on the device models and the more advanced solutions running on the cloud, will probably be more and more popular in the future. And yeah, as the on-device models may feel limited now, I think they are going to only get better because the hardware is getting better and the software is getting better. And as Apple continues to advance these on-device models, we'll likely see better and more accurate models in the future. And that's about it.
All right, if you guys have any questions.
Thank you very much, great presentation. I have one question. Are the tools, are the returned value from the tools put in the output of the LLM verbatim, or can they be further reprocessed by the LLM?
No, it isn't, because as I have shown, apart from the string, you can also provide this model with the dictionary. So you just define the key value pairs, like the key can be, I don't know, the temperature, and the value can be like 32, and then the model will have this information and come up with its own output in the natural language. And also, since the tools can be called multiple times, yeah, it just wouldn't work. It just creates its own response from these parameters.
Hello, thank you for the great presentation. So I have 2 questions actually. The first one is how fast does it really generate responses, and whether the battery saver, for example, affect that?
It's actually quite fast, I would say, for our use cases where we don't have like a massive input. It takes around 1 to 2 seconds. So I think it's pretty good when it comes to the speed. But I, for example, didn't like stress test it with 4,000 tokens window and see how it works. Probably it gets slower. And when it comes to the battery, actually, I'm also curious. We released the app yesterday, the update for iOS 26 yesterday, and we'll probably check in like 2 weeks because we are also curious if we will see something in the organizer where you've got the data about the battery for the users.
Thanks for the presentation and question about the embeddings. Can you access the text embeddings and vector search?
I can say with like 90% sure that it's not available as right now. So no vector search is possible.
Hi, so my question is about the token limit. I understand why we should limit the tokens when you ask the remote LLM, but why do we need the token limit for the on-premise model? Because you don't pay actual money, and it's not like the question is gonna ask a few hours to respond.
Yeah, actually, I think the person from Apple maybe would answer it, but actually, for example, when you are working with even with like the cloud LLM, and you provide like too many information, I think with this kind of not super performant model, it would just start hallucinating and probably provide some gibberish. So yeah, it probably wouldn't make sense. It's the model is too small to handle more input, I think. But yeah, that's just what I think. I'm not sure.
Sorry, I didn't mean to put no pressure on you.
Okay.
Another question is about saving the session, because you mentioned as long as you keep the session object, it keeps the context. So some information is worth persisting, like my name is John and I'm 29 years old, is worth noting for the future. So I didn't quite get if the tools are the proper nomen tool to do this, or maybe the session object is not too big to be stored in core data. So what's the preferred approach if you...
No, actually, could you like repeat maybe, because I'm not sure if I understand correctly.
Okay, so if you have some data provided by the user and given to the model,
okay,
and
yeah.
you want to persist it.
Okay, I understand. Okay, I understand. So the question is if we want to provide some additional context to feed into the session, I would say yeah, just maybe create like an extension on the instruction, and like with the example that I put with the language, you can just provide some additional information that will be fetched from something, or you can call the tool, but when you call the tool, it might be called, it might not be called. So yeah, if you want to make sure that this data is here, you should put it in the instruction on your own.
Let's give Michał a very big round of applause.
Thank you.